Hey folks. Just waiting for a few people to show up and getting some material together so we can take a look. For the people that are already in here, if you can hear me, be thinking about what kind of questions you had on the first assignment. I'm going to be extremely lenient on these exercises, and what I want you to do is, using the material provided and asking me for help. You can also, do your best. If it won't compile, or it has errors, you should ask me about those before it's due. But after it's due, if you need to make up any exercises or go back and fix any, I will allow that. So in here, I don't think anyone's communicated with me about, well, none of my, I know there's students I've had before that are in here, but I don't know. They haven't talked in the chat anyway. So, what was I saying? Oh, I'm generally very lenient in that regard. I want to do everything I can to help you learn and not have problems. Remove the stuff that gets in the way, because I'm all about just teaching. So, okay. 2, 3. Let's see. Pull that up here. Okay. Oh, here it is. All the textbook publishers are basically on a sinking ship that's on fire. None of them can swim. And so they are no longer giving professors physical copies of the book, but digital copies. Which is really annoying to me, because now I got to remember all these textbook logins. And though it is really nice to have a digital book because of the search. You can look up things so quickly instead of having to use the index at the back of the book. A lot of students don't know how to use the index, so I also try to talk about that if it's easier to explain in person. Okay. Anyway. 2, 3. Write a program that computes percentages for specific categories in a personal budget. Ask the user to enter estimated monthly expenditures, rent, payment, food, da-da-da. Okay, so did you make any progress on that exercise, Alex, or did you kind of run into that problem and you were waiting to ask me? Because if you already started on it and you have something kind of working, post that, or don't post it, but email me that Replit link, and I'll pull it up if you don't mind, and we can just actually do it together. I set this to have the minimal delay, but I still think it's fairly significant delay. So if I'm pausing waiting for you guys, I'm going to try not to do that, but it's because I'm waiting for the response. I guess I wouldn't have that problem if I use Zoom, but YouTube has a lot of awesome features that allow me to basically store the videos for free on their servers and edit them. So, let's see. Still waiting to get that. My weekends have been pretty busy, so if you email me on Friday afternoon or later in the day or Saturday or Sunday, it might take a while for me to get to that because I've been pretty busy, but I will get to it eventually. So, for example, I haven't looked at the emails since programs can be probably, you can find some similar stuff online. If you do that, though, I highly recommend making sure you understand why it works. If you do that and it works, but you don't know why, please ask me, because that's kind of the point of the class. But the internet has so much information. I really feel like teachers are too traditional in their use of the internet, which is basically don't use it. But it's one of the most, it's probably the best human invention. It's like an interconnected human, basically encyclopedia, but it's live. And anyway, logging in here. Okay. Oh, okay. We can take a look at why it won't work on Replit, Alex, so we can, so you don't have to do those extra steps too. It is really good to know how to use Notepad to create those files, though. Replit does have, so let's move this over. Here. Hopefully this isn't too aggravating watching me do this. Okay. Okay. So it doesn't work here, but it works in Notepad. Well, let me copy it into Notepad. And I figured out how to bring up different screens quickly. It was easy to find out. It was easy to figure out, but I just didn't want to do it during the class, make you guys wait. Okay, so I just have to turn on this screen. Set it to Notepad. And then let's see if I maximize this. Where will it go? Okay. Let's not maximize it. Okay, so we paste in the code here. And fancy transition. Okay. So we've got this, and I will now save as, I'm not sure if it shows the save as window, but if you haven't worked with a text editor yet for this class, basically you can use it if you need to. Maybe you don't have internet access for whatever reason, you need to work on your assignments, you can use Notepad. You just have to save the file with .html at the end. If you forget that, when you open it in a browser, it'll just be all the code that you've written. So if you see that, you just have to go back to your file and make sure you put .html on the end. You can just rename it. It should work in Windows 10, I believe. Okay, so we'll save this as 2.3.html. All right, and then I'll open that in Chrome so that way we can see the output. Perfect. Now I'm just going to add this to the other browser window. Okay. So, whoops, wrong. Nope. Yeah, this is the right one. I just need to switch back to this. Okay. Fancy transition. And I'll zoom in here so you guys don't have to use a magnifying glass. Okay. Okay. So I canceled it. That's why it says not a number. NaN is not a number. So some part of an equation output was not a number there, but it's because I canceled it, so it used some weird null value probably. Okay, estimated monthly expenditure for rent payment, 100. 100. 100. 100. Okay, so you got this, and then what did it say? It wanted your program should add the amounts and display the percentage. 2 decimal places and 1 decimal place. Okay, so it looks like you figured out the decimal places. So let me see why that's not working in Replit here. Okay, it says on the first line here. Okay, and as I'm looking at this, I'm realizing, let me copy this. We need to transition from using the JavaScript Replit to, I'll have to, well, hopefully people will see this in the video when they watch it, but we need to use this HTML, CSS, and JavaScript because one use of JavaScript is to add interactivity to web pages and just do all kinds of stuff, but the user interface is HTML and CSS. So we're going to be using JavaScript to basically build some web pages and manipulate them. Okay, so this is 2, 3. All right. Do that. will make this private. And not to be mean, but I don't want to make it as easy as just copying and pasting the code and submitting. Okay, so, oh, I know what the problem was. The problem the problem is we need this code that you've written needs to be in an HTML file, but you can't process an HTML file unless you are in this the HTML one. Okay. Anyway, before I forget what I'm doing, we can paste that, and then we should be able to see it in here. Okay. So let's do 1, 1, 1, 1. Okay. So okay, so you were saying these variables, okay, you've got %1 through 4. So I don't know how I don't think they were specific about how they want it, so I'll just do it. I'll let you fix the decimal. Well, it's right here. I can do it. Okay. So you're doing rent equals da-da-da, and then your rent variable. Okay. There is one programming standard that I should point out now, and it's good that we're doing this because I can look at this. I'm glad you showed me this, Alex, because this is really good. I just told you guys the wrong thing to program it in, but you've got everything here. But okay, so getting the percents, let's put it just right after the dollar amount. So we will put after here for the line break, put a dash, or a space dash space, and then we will put your what would you call it? Just %1, yeah. So variable names are case sensitive, and variables in JavaScript use first word is lowercase. So you don't have to change this unless you want to, but variables should have a lowercase letter to start. And the reason for that will become apparent when we get into objects. Objects are start with a capital letter. And so if you follow that standard, because the computer doesn't care, it'll work either way, but if you follow that standard, it'll make your code much easier to read for you and for anyone else that needs to look at it, like me. So if you had a longer variable, you capitalize every word after the first. Okay, so where were we? Okay, so we're adding this, and then we're adding %1. I think I put this in the wrong place. So I just need a plus here. Don't need these files. So we can increase the space here. These lines, when they get longer, they're more confusing when they wrap around. Very hard to read. So if you can, I recommend making yourself enough space to actually see your code. You can zoom in and out too. That might help. Okay, so I'm going to grab this. So this is everything between BR and the 2 fixed. Okay. So I'll just stick that. 1. And in Replit, I think you can do this. I'm going to hold Control and click another spot, and then I can just do this. Just put it in all the places. There's all kinds of tricks. This early on, if you don't have experience with programming, if you see me do something and you want to know how to do it, all you have to do is ask. I'll try to remember to explain it. There's 1.5 million things that you learn. As you do this more, it really is. You become proficient in the language and understanding. Okay. So now we have to calculate those percents, I think. You're not doing that yet. So you're adding them all together here. Okay? You're calculating that total. To calculate the percent, all you have to do is take the value. So you're doing rent first. We do rent divided by total. Okay, let's see what that looks like first. All right, I broke it. Okay, it says BR is not defined. Okay. So, oh, did I do that? No. Okay. Be honest with me, guys. Is this painful to watch? Okay, so this says undefined, which means, I think, because total was created without a value, it's defaulting to string data type, I think. So if we start it with a 0, let's see if it defaults to integer. All right, nope. Okay, let's open this in another window and we can actually see, here's some troubleshooting tips. These are invaluable. So 1, 1, 1, 1. We come in here, hit F12 to open the developer tools. Okay, and then go into the console and we can say console.log. This is a command that allows you to print to the console. So we're going to put the name of the variable. It says undefined. Okay. Let's try. Let me check if you guys have figured it out yet. Okay. I wonder if it's because percent. Oh, it wasn't total. It was. These also need to be. So when you create the variable name, that's called declaring the variable. So you're reserving that name for the program. When you initialize a variable, that is where you give it an initial value, and that sets its data type. These zeros right here, they're called integer literals. They're a literal, the value of 0. If you want to make it a string that has the character 0, what would you do? You'd need to put quotes. And in here, I think if you select something and you put quotes, it puts it around it for you. Save a little time. This would be the string of 0. So let me leave this one as the string and we'll see what happens. Actually, did I change those percents down here? Okay, did I change those percents in here? Sorry. Bear with me here. Percent. Yeah, okay. 1, 2, okay, 3, 4. All right. 1, 1, 1, 1. Okay. So it worked. I'm not sure why the first one worked because I set it to the character 0. But okay. One thing that's both good and bad about JavaScript, especially when it's processed by a browser, is a lot of the rules are super lax, which is unfortunate because the code doesn't always work the way you think it should, so it takes a little trial and error. But anyway, it shouldn't be 0, right? It should be 25%. Oh, you know what it is. It's 0.25. So, and it's cutting off the thing, the decimals. So I'll fix the first one, and then I think you guys can figure out the rest. Okay, so all we have to do is put the 2 fixed, set that to 1, because it wanted 1 decimal place on the percent, I think. Okay, and then instead of putting that, actually, let's do this. %1, since it's 0.25, how do I get 25 out of that? I multiply it by 100. Okay, let's see that. Oh, that's what I was looking for. I knew I forgot to put those in there somewhere. Okay, anyway. There it is, 25. And we can put, you know, a percent on there like this. Building strings is important in understanding how that works. So get lots of experience on that. So there's the 25%. So hopefully that helps. So here you're doing your calculations, and you need to do your calculations before the output. So yeah, and you have this compute total, perfect, and display results in that order. You could calculate one, print it out, calculate one, print it out. But to keep more organized, if I'm using, you know, a bunch of variables in this one output, I should be making sure before I do this they're calculated, or else I'll run into that NA problem. Or what's happening here is these are actually just staying 0 because that's what I set them at the beginning. So, okay. If I take away the times 100, I want to know if... Oh, I didn't show you the 2. Okay, so if we do this, this will actually evaluate to a new number, and then from there, I believe we can just do this. So put a .2 fixed on the result of this equation, or expression. Sorry, not an equation. Okay. There's the 2 decimal places, and I wanted to see if this would, well, kind of know that it'll be 0.25, don't we? Okay. So anyway, we wanted at 1, and if you want to display, if you calculate out a percent, it's going to be a decimal. So if you want it to display as an integer or whole numbers, not decimals, you need to multiply it by 100. Okay. Anyway, they like to use math in these exercises, even though it's fairly simple math, because it's illustrating the strength of, you know, computer programming and using a computer to solve problems. It's much faster. Okay, let's see if you guys are bored in here. Oh, thanks, Alex. Okay, I've got it. Yeah, so again, if you guys ever spend more than an hour on something like this, because if you enjoy this, you will get to the point where if you get a problem and you know enough about things that you're like, I should be able to figure this out, you might spend like upwards of 8 hours trying to solve a problem, just looking up and trying things over and over again. I really don't want you guys to have to do that when you're in this class. Outside of this class, I mean, since you've been my student, you can always contact me if you need anything. But make sure you contact me if you're stuck and it's taking you more than an hour to do it, because I really don't want you wasting your time. Okay. Looks like there's 6 people watching. Does anyone else have questions? Okay. I'm not sure if we finished our PowerPoint. First of all, are there PowerPoints? I think there were. I should have rewatched the last video. Where are we in this class? Okay, because we missed last time because of Labor Day. I really should have made another video, but I don't think you guys mind the extra time right now, right? Okay. Let's take a look at this, and I just want to touch on some things, some of the more complicated things in here. And as we're looking at things, I'll randomly tell you, remind you of what it is, if I think it's important. If you see something and you want to know more about it, just ask in the chat or email me. Okay. Wow, I don't even think we started this, did we? Okay. So I wanted to show you another cool thing. See if I can find it. And so this thing I'm going to show you is something that you could actually build if you complete the programming program. Right. Okay, wow. So this is a, let's see, I gotta pull it onto the window here. I'm trying to be more cognizant of what I'm showing you, so I'm not talking and you can't see anything. Okay. Anyway, there's a bunch of these sites, and I'm just gonna go with this one for now. But if one of you can find, there is a website that has a list of the most popular programming language on GitHub over every month, and the results of what I saw were a little bit different, but Python, and what are these percents? What is this based on? Oh, how language tutorials are searched. Okay, so this is all what languages have been searched the most. So here for this class, JavaScript is number 3. Some of you might be in my Python class. If you're not, the reason this is so popular is Python is one of the simplest programming languages to do simple things with. So if you just need to calculate numbers, a lot of people doing research use Python to run their statistical data analysis and stuff like that, because you just have to type it in and tell it what to do, and it will do it. You don't have to worry about a lot of things. So anyway, I wanted to show you this so you know learning JavaScript is a very valuable skill. You know what? This is based on Google searches. It's probably Python is the most searched just because it's the most accessible. It doesn't have to do with anything else. Where can I find this? Okay. Most popular languages on GitHub. it's not this. Welcome to Logic, the class where you watch me search Google. There we go. Is this it? Okay, anyway, if one of you guys can find it. Someone showed it to me. It was linked on Reddit, but they never shared me the link, so anyway. So this one is saying JavaScript ranks first on the 10 most active programming languages in GitHub. The thing that I saw, JavaScript and Python are both like, they're ahead of the pack. So the reason is JavaScript is so versatile, and it's just like a half step above Python. Much more technical than Python, has a ton more rules, but it's a lot more powerful because you can use HTML and CSS as a user interface with it. It's embedded, so you can put it right in the file or create its own file. A browser can run it. JavaScript is run on your machine. The code uses your machine. So if you visit a website that uses JavaScript for whatever you're doing, your machine is processing that. So, and you can also see the code. All right. Anyway, this is a good language to learn. Okay. None of this, well, some of this is important. Okay, so if this is your first programming class, or maybe you're in my HTML or my Python class, those are all like the earliest ones, the earliest programming or coding classes. Those all are languages that use something called an interpreter. So when you write a program, the code is either going to be processed by a compiler, which processes all the code right away and creates a package of a binary package that'll the program will just run when you open it. Okay. Languages that use an interpreter, the code runs on the fly. So as you click on things, the code will run. And the problem with that, two things with that, it's a lot slower than compiled programs. So again, that's why Python is really good for small things. JavaScript's pretty good for small things too. Those use interpreters. Things like Java, C#. In the programming degree, you will use C#. It's one of the most modern languages in use right now. Has a ton of features. Another thing is compiled programs will tell you their errors, syntax errors ahead of time, where interpreters won't tell you there's an error until it actually interprets that line of code. So a little bit harder to decode, or I'm sorry, debug interpreted languages. If you don't know how to use the tools, JavaScript is a nightmare to debug. But if you know how to use the tools built into the browser, you can be very quick about it. Being able to debug quickly is one of the most important things early on. It'll make this a lot more bearable, and those skills will be very useful for you in your actual job, for sure. And you'll notice as you do this more, you'll make less errors as you go. So, but you do need to make sure you understand the errors and how to fix them. Okay, anyway, that's what that is. So these are compiled languages down here, and you will see C#. Okay. Cut the program down to 3 languages recently: C#, JavaScript, and Python. if you know C Sharp, Java is not that far of a leap. The thing with Java is it's cross-platform, so it doesn't matter if you're using a Mac or whatever, Windows or Linux. Java can be processed separately from independently of the architecture of your machine. Okay, so that's why it got really popular. All right, and the newest one. Okay, here's a little trivia thing for you. You know, here's C. You may have heard of these, you may have not. C++, and then C sharp, because it's like a musical sharp note. I think this works in JavaScript too. The plus plus is an increment operator. So let me show you this. Okay, I'll just delete this code. And we can do console.log. Where did I put that? Okay. Okay. So if we have a number, oh, here we go. I'll just use this one. If we have a number, like 1, we can store that in a variable. So let's call it C. So the first version of the C language was called C. Secondly, the new version of that, it's not very new anymore. I don't even think C sharp is that new. It's the newest. If I do this, okay, we'll see what that comes out to. And then, why did it go to a sharp? Does anyone know? I'll never get your messages before I actually get to it, but does anybody know why it went from C++ to C sharp? It's kind of ridiculous. So it's actually just 2 sets of plus plus on top of each other. So it's like this. If I want to get to version 3, I use this C++. That'll take the number and increment it by 1. So up here, this will be 2. But if I do this, C++, should come out as 3. And you guys, I'm showing you all of my really bad habits here. Okay. So let's debug this one together. It's probably just not going to let me do this. This is the problem. Okay. Invalid left-hand side expression in postfix operation. That sometimes helps, but this is, it takes you a while to understand what these mean. Because it's usually just a typo you made, so the error it's causing doesn't always necessarily relate to what you did. You probably just made a typo. But the important thing is here, it's at the 4th line, 13th character. So 4th line, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So right here, when it gets into here, it's not very happy. So let's see if I can do this. I don't think that'll work either. Okay, so we'll just do this. Here we go. So we'll do C equals C++. And C equals C++. What was that going to do, right? Okay. Maybe I got it backwards. Okay. So if you put the plus signs in front of the variable, it will do the math before displaying. If you put it after, it will change the number after displaying. And there are times when you will need both of those, and then there are times when it doesn't really matter. So just understanding the difference between those can be useful. Anyway, so all of that to say, we're never going to get through all this, right? Nah. So if you guys do need to go, I plan to just keep talking. So if you don't have a class and you want to hang around, you can. If you need to go, when the class is over, you can. If you need to go now, you can. This will be recorded. So anyway, I'll keep rambling on. So C incremented by 1 is C++, and then to do 2 increments, you need 4 pluses. So the sharp is actually just 4 pluses put together. And I guess C# rolls off the tongue better than C+++++. So there are probably people that would have liked to name it that. All right. The generations of languages, I don't even know if I've heard of that before. That is not really all that important, I would say, to understand. We talked about that. Okay, so scripting languages doesn't run as a separate program. So it's ran by some other program. For example, for Python is ran by the Python interpreter. JavaScript, in our example, well, in the examples I showed today, are being interpreted by the browser. Okay. History of the internet. Basically, in a nutshell, university had a project. They wanted to send a message through a cable from one computer to another. They were successful, but as you know, academics aren't funded as well. But you know who is funded? The Department of Defense. When they found out someone had created a new form of communication, they said, "Take my money," and it exploded from there. Okay. Then the web was added eventually, so messages could send messages that could be interpreted by a browser, which is what, part of what we're doing here. Okay. That's, other than that, I don't know if any, it's not really that interesting. You can go back in time before this, like history of the computer. That stuff's pretty interesting, actually, because if you understand how that works, it's really useful for debugging. Okay, but it's kind of a higher level thing. History of the internet, so you can see 1960s, the internet existed, and then 1989, the internet, HTML was invented. Okay, and so there, there was 1993 was the first graphical browser. So I never had a computer in 1993. I would have been 5. I had a Nintendo, but in 1993, that doesn't seem like all that long ago, huh? But we're so used to graphical browsers too. Back in these days, computers weren't even graphical. Back here, okay. Yeah, so like I said before, the main use of JavaScript is interaction with websites. So that's very, very narrow description, okay? Websites, it does work on websites, but nowadays I prefer to call websites web applications, because you can build a web application using JavaScript and HTML. Okay, so you're not just making a website. Okay, you can build a tool using it. Okay, anyway, boring stuff. All right. How many of you guys are in my 099 class? We still got 6 people watching. Anyone in the 099 class? I have like 12 classes, so it's hard for me to keep track of who's in what class. I'm glad Canvas keeps track of it for me. Okay. Anyway, if you're not in the 099 class, we actually specifically focus on these things. So in this class, you're just using them as a cheap UI. So a super easy to program UI. Okay. Okay, and then this talks about how you set up a script. Now, I did want to show you guys. I'm not sure if it shows you in here. If it does, it's okay. I want to talk about this now. As you're doing your assignments, in this example here, you'll notice my JavaScript is in a script.js file, okay? So it's a separate file. How does the website, in this case, know to run this code? What ties them together? Okay, so take a look, because when you hit run, what in this HTML replit, when you hit run, the first thing it's going to do is interpret this index.html from top to bottom. You'll notice a lot of code is interpreted top to bottom. I have not encountered code that is not interpreted one line at a time from top to bottom. Okay, which helps with debugging to understand that. So anyway, in the index.html, this is all boilerplate stuff. And then right here, this is the important part. This is how you set the file to run, okay? So you put script, src for source, and then the file path, okay? In this case, it's the name of the file because they're in the same folder. If it was in a different folder, say, you'll see this commonly on websites, they have a JS folder, and that's where they store all their scripts that they're going to use, okay? If I put that in there, it can't find this. And I think if I open this and I hit F12, again, F12 is your best friend in this class anyway, it says I could not find script.js. Well, it's in that other folder, so we have to change the file path to porting, so it'll let you catch up once it gets a connection back in. Okay. Should hire someone to edit these videos for me. With everything else I'm doing, I try to cut off the blank space at the end or at the beginning, so okay. Sorry. I'm a beekeeper and I got stung right on my hairline and my forehead is completely swollen and itchy, so that's why I keep touching my face. Okay. So it printed out the 1, 2, 3. Anyway, why would you keep it in a separate file? So, a lot of reasons. One is if you include code in your HTML file, so you can also just you can add as many of these as you want. You do have to include, or do you? Let's see, console.log. Yeah. Let me put a closing script tag. The crazy thing, and if you know HTML, you may understand this. If not, the fact that you have to include the closing script tag even for, accessing another file is funny to me. Anyway, so we have another script here. Okay, so you can have multiple scripts. You can load in multiple files. What you want to do one thing in programming that you want to do is this idea of separation of concerns. And so on the highest level, that is, at least for JavaScript, and that's just organizing your code into files. Okay. You don't want it on the HTML because that will be every character you include of code in the HTML file will have to load or be transferred when someone visits the website, they're downloading that web page, they'll have to download that. So it makes the file bigger. And the programs we're creating are so small, though, it's insignificant, but those are, those are example programs just so you can kind of practice. Okay, but a real program could potentially be much larger, and larger the file is, the slower it's going to load. So if we off-put that code into a separate file, it will only be used when it's called here. So when this web page gets to this point, it's almost like the code in this file is just kind of copy and pasted into this spot. It's kind of how you can think of it. Okay. Now, we aren't doing it yet, but in our scripts, or in our exercises, we're going to be manipulating HTML. And so, why was that important? Why was that important? Okay. I need to rewind and check out what I just said. Okay. Anyway, you should separate out your code, and if you're writing a program in JavaScript to do something, it should do that one thing, and then if you need something else done, you should make that into a separate file. And that way, the pages only need to load the scripts when they need them, and people don't have to download more than they need, thereby speeding up your site, which is one of the biggest and most important things. It may have changed, but someone keeps track of or does research on load times versus retention. And so if your website takes longer than a half a second to load, a lot of people just leave. So especially if they try to use it more than just if it takes 2 to 3 seconds to load initially, but every time you click a link, people are going to leave. So every little thing you can do is important. Every bit and byte that you can save is very important. It's all about speed and efficiency. The computer will do literally anything you tell it. So if you tell it to, go to the top of the Empire State Building, but instead of going east to New York, I want you to go west around the world to New York. And the computer will just do it. Okay, and so what does that mean? How does that work into it? Well, when you're including all the code in here, or no, when you program something one way, the computer's not going to tell you whether that's the most efficient way to do it, is what I'm telling you. It'll just do it. So you have to learn the most efficient way. And trust me, these beginning programs you're doing, I'm not worried about efficiency when I grade it, but I will... Oh, good, a bunch of you are in 099. Okay, so you're going to see some overlap, and it'll be very helpful. Okay. I should stop looking at the chat in the middle of an idea, or middle of me talking. Anyway, the thing to take away is computers are dumb. They can count really fast, but they can't make any decisions on their own. Okay. Even the current level of artificial intelligence we have, was created by a person, and the data that's fed into it to make it intelligent is chosen by a human. So it's influenced by human hands, and the decisions it's making are just a complicated compilation of way more data than a person could even process in their lifetime in milliseconds. So that's cool. Will artificial intelligence be the thing that saves mankind or the thing that destroys it? Everybody's waiting with bated breath to find out. Okay. I gotta continue on or I'm going to keep rambling. I love talking about artificial intelligence. And if you're unaware of it, look up, this is on Wikipedia, look up the singularity. It's kind of a cool idea. We may be in a post-apocalyptic world soon. Especially if you like the movie Terminator. Terminator 2 is the best one, though. I recommend it if you haven't seen it. I think it holds up. All right. So we know all that. Okay, tags and attributes. You can read that. If you're in my own 99, there's 2 of the 3 things that I repeat over and over again. Even in this class, you can't escape the tags and attributes. What was the third one, though? Right? Let's see if you can remember that. Okay. Why do they tell you this? I don't know. You don't need to memorize this. But it is important later. JavaScript is considered an object-oriented language, which means you can follow a very efficient framework. You don't have to, though. You can write it line at a time, which is what we're doing here in the beginning. Writing code a line at a time makes it extremely difficult to reuse the code, which is super important for efficiency, and it makes it hard to change because it's usually super specific. When you use object-oriented programming, you kind of break everything up into something that doesn't even look like programming. Okay. We will use, okay. So in this example, this is the document object. So we will be using objects, but we won't be creating our own objects for a while, I believe. All right. This document object is automatically created by your browser when you load a web page. It contains all the data that's on the web page document, and it has methods which allow you to manipulate that. So here, what this is saying is the document object, I want to use its write method, and I know this is a method. What you can expect here would be variables, which are called properties when they're of an object, or methods, which are just functions of an object. The way I know this is because the name has a parenthesis right after it. Methods and functions always have parentheses that allow you to pass in the arguments, okay? Even if the method or function does not have any arguments, you still have to put the parentheses. So that way, the computer knows you're talking about a method and not a variable, okay? So if I don't think there's any tools in here that I can use. Okay, I should download this. All right, that way I can edit it. Anyway, let's take a look at this. Because in Replit, they have some, it's nice because it's a programming text editor. If I throw this code in here, we can see, I'm using the console object too. Also, I might have been wrong about the object thing. There are different standards for different programming languages, so all you have to do is look up the name of the language, programming standards. That'll tell you how they name the variables, how they do their indenting and spacing, What else is there? Oh, right, variable naming, object naming, syntax differences, important syntax differences. Because a lot of this plus plus thing here is in, I wonder if it's in Python 3, but it's in Java. It's in all the C languages. This is a very common operator to see in a programming language. Okay, console and document.write, or just document, these are specific to the browser that you're in. Okay, and so that's why when I say console.log, it prints out down here. And just so you're not confused, you don't have to use Replit to see the console. You can just hit F12 and you can open the console in these developer tools. That's really useful for it to be down there, huh? There we go. Sorry about that. Bear with me here. Yeah, we don't really care what's new right now. We want to know what about the old stuff first. Oh, that's why it's doing that. Okay. Sorry. Okay, so here is the console output that you can see. One nice thing about the console is it's really good for debugging because it won't break whatever is on the page. So you can print out variable values so you know at what point what value they are. We'll look at more efficient ways to use that too, because there is a very powerful tool. Oh, document.write, we want to see what that does. So that's going to put it in the browser window. And the other thing I want to show you is how you can see what your options are for methods and such. And also so there it is, it drew it on the web page here. All right. So for this, you can actually include some HTML. And so what happens here when you use document.write is it hands this off to it's interpreted by the JavaScript interpreter. When it gets to document.write, it feeds this code, h1 variable 1, h1, into the HTML processor, and that's why it shows up on the screen. So multiple steps there. That'll happen for you in the background. This is why this is a popular programming language, because the internet's popular and it is fairly powerful. Okay, so that variable 1 is showing. So when you're using an object, let's see if they have this. I might have to switch to a JavaScript one real quick to show you guys this. New REPL, JS. Okay. So if I do console dot, okay, maybe there's a hotkey for this. There we go. I might have turned, oh, I actually turned mine off because I found it annoying. All right, there we go. Yeah, there are settings in here if you like to work at night. This one is an eye saver for sure. And since we're not on a projector, I can use this. And you guys can still see it, hopefully. and this way if you watch this video at night it won't burn your eyes out. Okay, so now if I do console dot, what this is showing me is there is an XML file that's in Replit that tells it what all the built-in methods of JavaScript are and the objects. So if you're using a text editor that has this, I recommend doing it, especially in the beginning. It's awesome because memorizing the syntax is a nightmare. You can just type it and put a dot and it'll show you, all right, all the methods. So they're the purple cubes, and it says it here, method. And then if you click I think it'll expand this. It says console.assert, you have to provide it with a true or false value, which is called a Boolean value. And you have to provide a string, and you have to provide, it looks like, any array. Okay, I've never used that, so I don't know what it does. It's probably, here's my guess. It looks at an array, which we haven't talked about yet. It's basically a variable that can hold multiple values. But it's a little more than that, but we'll get to it. Anyway, I think what it does is it takes a list of values, and then if a value evaluates to true, it'll print out whatever string you put in as a message. So maybe we'll try that when we get closer to learning about those arrays. Okay, document is another, so console is useful. Document, you have to use it. You pretty much have to use this one a lot. And you can see it has a ton. These blue rectangular cube things, box-looking boxes, these are properties. So, okay. Let's try this. Document.content type. We can print that out in the console. Actually, I'll have to go back to here to do that. Let's do document.content type, and let's see what it prints out. So again, I had never used this one either, but I'm just showing you how you have to kind of explore a little bit yourself. And there's too much to learn at all. So you have to really, what you should focus on in these courses is getting a good foundation in the basics, not memorizing a bunch of things that'll probably change slightly later. So it's like learning a bike. Try unlearning riding a bike. It's much harder. So we paste this in. And we'll actually, let's put this to print out on the screen. So instead of printing this string, we'll just print this string. And it says, this is a text/HTML file. All right, cool. I'm honestly not sure what else it would be. Okay. So there's my rambling on that. All right. I think, okay, so if you encounter a question in the exercises that asks you to write something in pseudocode, don't write it in pseudocode. Pseudocode is something you should learn towards the end of knowing the basics. It doesn't make any sense to you at the beginning. So we're not going to learn it right now. So in a nutshell, anything can be pseudocode. I could say, write a program that asks me my name and prints it out. And the pseudocode for that would be ask for name input and then output name. Like that would be pseudocode. Okay, why is that useful? I can tell you why it's useful for now. One of the biggest problems in technology, any projects in technology, so developing software, hardware, anything, they have a very high failure rate. So you can spend a lot of money and years on a project that just fails. Using pseudocode, you can kind of plan. Planning is a multi-step process, but planning is extremely undervalued. And so if you go straight to coding on anything in a professional environment, what's going to happen is you're basically be using trial and error. And you might write some code, and then you'll encounter this actually happens in programming all the time. You'll hit a block, you'll research it, you'll realize the way you've done it won't work, and you have to scrap that and start over. Okay, that is very common in programming. Okay, that's really hard for some people to do. You have to understand things that you work on could be just canceled by the company to save money. They could be, they could just be failed projects. So it's really important to plan. And you might, when writing pseudocode, you're just writing out the steps of what you want the program to do, basically. And you can do it as generally as I said, or you can break it down into more steps. The more specific you are, the more you're going to have to write. But it will be probably you want to balance. So none of the exercises in this class need pseudocode because it would literally be like 2 lines. But in a real application that people are actively working on, you're going to want to start by writing pseudocode so you can identify those things that'll cause you to start over before you spend a bunch of time troubleshooting and getting the wrong way to work. Okay? Which it'll happen anyway, but it always happens until you are like a genius, perfect programmer, which I don't even consider myself because I'm more of a teacher. I know all this stuff, but I don't use it in a like a professional. I don't do it professionally, programming. So, and you may ask, well, that's fine, but I guess I would prefer someone with more experience actually in the field. Well, I do have an advisory council of maybe 12 programmers from SSI, Smart out of Effingham, Patterson, all the big companies around this area. That we meet and stay in touch throughout the year. And so I run things by them, and they tell me the newest stuff, and I include it in the class. So it's not like I'm just guessing. Here's the thing. Any class you take, unless you know the material already, you don't know if what they're teaching you is actually useful. But the material I'm teaching and the things I'm going to point out are important are because people that do work in the field and that I have a professional relationship with have told me this is what we want in someone that we would hire. So that's why my classes are very loose. They're project-based. I hate memorization because it is not memorization is going to help you so little in programming. What's going to help you is working on your critical problem solving skills, which easier said than done. Okay. This is a weird question, but are any of you guys super interested in math or fans of puzzles? those are useful things. The math thing is for very complicated programming, very high level programming. But okay, I'm just gonna not finish a lot of my thoughts if they're rambling. If it's important stuff, I'll make sure to say it. Okay. Okay. Include your semicolons. You may have noticed sometimes I forget them. Some language, I guess most languages use them. Python does not. It's just a way so you can signal the computer, hey, I'm done with this line of code, and you can start on the next one. So just saying, it's like some kind of telegram. Beep, 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 beep. Stop. I am coming to visit. Stop. Make sure you prepare. Stop. Like that. The semicolon is the stop. The computer goes zzz, stop, zzz, stop. Anyway, so with JavaScript you don't have to include those. And why you don't is because it's either Chrome or JavaScript or both. Just put them in for you afterwards. So it's a really good thing to include these, because if there is any kind of confusion by the computer about when the line ends, it'll just break everything. The other thing is because of search engine optimization, which I think I talked about in the 099 class, but some people believe to get your website higher on Google and higher in Google search results, which directly translates into, if you make it to the front page, a lot of money. If you make it to the second page, maybe you'll get some money. Past that, you may as well not have a website. Anyway, proper coding standards may be analyzed by the Google web crawlers that read your page, and so you may lose points because you didn't include semicolons. Now, that's just a total guess. Search engine optimization is a complete guess. Some things are probably obvious, like if your page doesn't load, they probably may not even include it. Anyway, okay. They're showing you how to use Notepad. Okay, it's good to know how to use Notepad. Like I said earlier, Notepad, Notepad++. Another one, I'll post these in the chat so I can actually use this thing, right? And then I'll see what you guys are saying. All right. So you already have Notepad if you have a Windows machine. There's a text editor for Macs you can use. If you're using a Mac, I think the best one is brackets. Actually, why am I typing it in chat? I can just show you. Okay. So this is a really good text editor for mostly CSS and HTML. Not bad for JavaScript either. Okay. But it has a lot of features for CSS and HTML. And I know, pretty sure it has Mac support. So if we go to download, should see an option for that. Does anyone in here have a Mac, primarily work on a Mac? Web developers like to use Macs. Any more with virtual machines, you can just have one computer and just load whatever image you want. Okay, nope, that's just going to download the one I need. Oh, here we go, other downloads. All right. Yeah, Mac and Windows users. Okay, so you would just download the right one there. It should auto-detect for you. So that's a good one. If you like text editors, check that one out for sure. It has a ton of awesome HTML and CSS features. The other one, this is probably the leading text editor for programmers. Okay, it's called Visual Studio Code. It's awesome. It's free. It has so much support because so many people are using it that it actually has a plugin library, so you can do all kinds of awesome stuff. You can get debuggers, you can get all kinds linters. Just I'm trying to think of what add-ons I've used. There's just so many for every application, but this has a lot of cool coding features just based on this picture. It has the dark theme, which is almost required if you work at night. You can have multiple files open. It doesn't show it over here, but it actually opens the directory of your program, so you can see all the files for that and quickly switch between them. It has, there's an add-on for GitHub support, so you can use version control software on your project. Okay, so we'll go into more detail about that when we need to. Those are things you can Google if you want, if you're bored, I guess. It has this nice picture of your whole code document because it can get pretty long, so you can kind of click in there and jump up and down. It keeps track of where the lines you changed last. Anyway, my favorite text editor for pretty much anything. I think I would use brackets for if I was just using HTML and CSS, but that's so rare anymore to do that. I mean, you'll do it in the 099 class, and the reason you do that is because that gives you hands-on experience with HTML. Now, I'll be honest with you, most modern websites are built using something called a web framework. And those web frameworks are programmed in Python or C#. I need to close my eyes when I'm talking. What was I saying? Oh, right, using HTML. It's a good experience because if you know how it works, you're going to be primarily working with HTML using JavaScript. Well, anyway, those web frameworks, they build the HTML for you, which is amazing. Basically, what's happened is we've got to the point where everyone's figured out the best way websites should be, and so they've created a web framework with all of those standards built in, so you don't have to research what the best way to do this is or that is. You just tell it to do it and it does it, as long as you know C#, which is one of the strictest languages. If you learn Python and JavaScript first, it's going to be kind of rough to learn C#. It's still that way the other way around. If you learn one programming language, JavaScript's awesome. It's a really good programming language to learn first. It's easy, and it translates up towards the other more complicated languages and down to Python. So it'll make you ready for all of that stuff. Okay. Let's see. So that's talking about text editors, right? So here we have common mistakes. Okay. It's nice in Replit because you can see the color coding, and once you learn the color coding, you'll be able to notice, hey, I see a color. It's literally like a second instinct that you'll learn. You'll just look at the code. You won't even read it. You'll just look at the code, and you'll see a color where it's not supposed to be. Okay, you'll get to that point if you keep doing these exercises and you understand to look for these colors. Okay, most of the time when I was in the classroom, when we're in the classroom, I would go around to the computers and check people's code. If it didn't automatically fix when I walked near them, it was usually a typo, which usually changes the color of things. So where could I do that? here. So if I forgot to do, whoops, what button did I just press? If I forgot to put an open parenthesis here, it thinks that write document is an object of document, and content type is a property of the write document object, which is within the document object, which is not what we wanted. So anyway, write was write. We know is a method, so it should be purple. Okay, you'll get used to those. All right, I was going to look at your questions here. Oh, favorite framework, Python Flask, Python's Flask, and that is the class, that's Web Scripting 2, is learning Python Flask. It'll be your first introduction to, if you take it, it'll be your first introduction to web frameworks, sorry. Anyway, it's for web frameworks, calling a web framework light is kind of an oxymoron, but of the web frameworks, Flask is probably the simplest and has the least overhead. What it is you write Python code that generates HTML code. So when someone visits your website, they don't download a file from your server. Python Flask grabs that request and it gets fed in through Python Flask. So whatever address they go to, Python Flask has code written for that address, and it will use that code to generate a web page and send that to the person. So that allows you to have dynamic web pages. So if I go to Canvas and I look at my account page, it has all of my information in it. If you go to your account page, it goes to your information. So that web page is just a template that web framework uses, and then it pulls your data from a database and just puts that in the web page. So if any of you guys are in my database class, that is also extremely useful for this. Okay. Here we are in the first and simplest programming class. I'm already telling you about the most complicated stuff that you'll do, so don't get scared away. It's stepping stones, it really is. Okay. The other thing is about pseudocode. I don't know if there's actually a standard. Just describing what you want the program to do is pseudocode. So they make a big deal about it. If you interview for a programming job, one common thing they like to do is ask you a programming question, a programming problem. So something like, if I have a list of random numbers and you want to sort them by reverse numerical value, write code for that. And at that point, if they want you to write in a language you don't know, you can tell them, okay, and then just do it in pseudocode, because pseudocode is one level above programming. If you write down the pseudocode for a program, you can give that to any person with any programming language, and they can interpret that into that language. So it's kind of a blueprint that is platform. It's not locked to one platform. But again, kind of writing it for these little programs is kind of a waste of time. Okay. It's like, oh, you don't have to declare variables in your pseudocode. That's right, because you would just say, store this value. You wouldn't even have to tell it what variable. Whoever's programming it would get to decide the name of the variable. Okay. Okay. Whoa. Okay. I wasn't looking at the time here. let's talk about what I want you guys to do next. I actually was supposed to start my stream for the other class at 2:30, but I'll just finish this up and go into there. It'd be funny. I think some people subscribe to me, so some of my students in that class might come in here. Okay. So the assignment, the last assignment, Chapter 2 multiple choice, September 17th. Okay, it looks like I had... Oh, it's one problem per date. Okay, so I guess just keep following the due dates here. So if you get done with all of the chapter 2 stuff, feel free to move on to, it looks like we're skipping to chapter 4 here. So you could take a look at that in the book. Oh, or take a look at the PowerPoints. And, you know, you're always allowed to work ahead on this stuff if you want. If you are the kind of person that wants to learn more than the basics, if you get done or you get far ahead and you want more like practice with a little more complicated problems to kind of make you think, just ask. I'll probably post that. I have a website with some really cool programming problems on it. And you get to create an account and submit your solution. And if it solves the problem, you get points. And they rank the problems by difficulty based on how many people have been able to solve it. For this class, there's some of the easier, saying there are easy ones. I think I tried the easiest one, and that they said was the easiest, and I had to give up at some point. But I did have students in another section. 3 of them teamed up to solve one of the problems, and they actually got it, which was really cool. So if you do want to be in this field, here I am, I'm like, I need to go. And I'm still rambling. Okay, well, I forgot what I was going to say anyway. So, I'm going to stop the stream here, and then I'm going to get into that other class. And you guys can move ahead if you want. Alex, I guess you're all caught up, so you can just hang out for a week or so, or work ahead. It's up to you. Thank you guys, too, for showing up. Even if I just have one person in here, when I record videos by myself, it's so different. But even if I have just one person watching, it just makes me way more efficient. Okay. So I'll see you guys. We'll probably look at chapter 4 stuff next live stream. And I'm going to try to ramble less. All right. So be thinking of any questions, and email me if you need any help. I did have a Zoom call with one student to help him get started. So if you need one-on-one help, we can totally do that. You don't have to communicate through just email, which makes things slow. Oh yeah, what is that website? Okay. I'll just post that on Canvas now. If I can spell. All right. Here it is, Project Euler. So these problems are more about creating algorithms that will solve a problem, which to me is the pinnacle of computer programming. In the class, we're mostly building and manipulating a UI. We're not really utilizing computer science, but for these problems, you have to utilize computer science. So you might have to do research on things. Okay, some of these easy ones are things that I have done. Okay, so you can start at the bottom and work your way up, or you can skip ahead. This one, there's something about longest path. Oh, no. I really want to show you this one, even though I'm supposed to go. Oh, you know what? If you're, oh, I'm on the wrong window here. Sorry about that, guys. Guys and gals. Okay. So it's projecteuler.net. I'm going to post this on Canvas, and you don't have to register to do the problems, but I think it's kind of fun. I think I have a score of 0 because I never finished the one I started, but the points don't really mean anything. They just make you feel better or make you feel worse if you have 0. Okay, so I'm just going to put this in important information. Extra challenge problems. Now, you know, at this point in the class, you may not have the basic tools yet to even attempt some of these problems, but it won't take long for you to get to that point. Okay. Wow, the way she built this class is so different than the way I do it. Okay. Problems, and you guys get an inside look at how fun it is to use Canvas as a learning management software from the back end. Now, it's the best one I've ever used, but they're still a bit clunky. Okay, so put that in there. So you guys can click that if you want to look. Okay, so let's look at it was on level 2. Here we go. I think it's this one. Okay, so here's my example of what an extra challenge problem would look like. Okay. All right. Given any triangle of numbers like this, you have to write a program that will tell you by going down through the triangle what path will give you the largest sum. So you have to write an algorithm that can read in, you know, numbers into such a structure that you can understand how they would stack. You know, you're not going to, you're going to have to store these as integers. But you need some way to know that this is the top, this is the second row, these are on the third row in this order. So with the tools you have, I think this is possible, but it would be very difficult because you need to be able to use loops and you need to be able to use arrays. Probably arrays would make it a lot easier. Anyway, so that would be like a problem that I would assign you after we got the basics down, or not assign you, but expect you to be able to work on. This first one is a very common programming question in interviews because it's just complicated enough to trip people up. So you have to write a program that's going to look at every number between 0 and 1,000 and calculate the sum of any numbers that can be divided by 3 or 5 So if we did 1 to 10, 3 is evenly divisible by 3. 5 is not, but it's divisible by 5. 6 is divisible by 3 evenly. 9 is, so you get the idea. But you have to do every number between 0 and 1,000. Or 1 and 1,000, I guess. Either way would be fine. And then you have to add up all the results of those numbers together. So this wouldn't be that difficult, I don't think. You would need a loop, though. Pretty much any algorithm, you're going to need a loop. Unless someone finds, like, some weird, efficient way to do it. A lot of artificial intelligence these days is discovering solutions to things that we would have to stumble upon. We would never be able to realize what this thing has found. AI, detecting cancer cells, even creating new recipes. It's a computer, it can't taste. But cooking and food taste is just chemistry. So you feed it in all your chemistry knowledge about what things taste good and what combinations, and it will create new recipes. And it's been quite successful at coming up with stuff that we've never tried before, which is like the weirdest application of artificial intelligence. And you can find there's a computer that played Jeopardy. That's is it IBM's Watson, I think. So, okay. Anyway, I should post that video. All right, I'm going to stop now. Oh, can I remove the HOA13 optional assignment? Let's see. That's in here. Oh, yeah. Has anyone done this yet? 3 people have submitted it. Okay, so hopefully those 3 people aren't mad if I turn that off. Always look at the bright side. Anything related to programming that you do while you're from now on, basically, anything is more practice. And this, you have to practice. I don't think it's going to let me turn it off. Yeah, it's not going to let me turn it off. Was there an issue that you were having? Alex, was there a reason that you wanted me to remove that? I think it says optional, but it says 10 points. I'll just turn the points off. I'm not sure why I left this one in here. regrade those submissions. Uh-oh. Oh, okay. I think Alex, if you, I'm not gonna penalize anyone for turning in something that's wrong. If you just submit an empty text box, it should fix that. And I'm not gonna. I'll know if you submit it. I'll know that as an empty text box, then it should go away on your missing assignments, and I'm not gonna take it for a grade anyway. So. Yeah, in my next class, we're going to be we're installing the Flask framework on Amazon Workspace virtual machines so that we can start making our first web app in that class. So I'm excited. I'm excited, except working with Linux in person, it was easier because I could just help people, but we're going to see how this goes. We'll see how it goes. Luckily, since they're Amazon Workspace VMs, if you mess it up, I just have to click a button on a website and it just rebuilds the whole computer. So. And those are paid for by a donation someone made. So I could not do nearly as good of a job without that as an option, because the school network is just too slow and does not like when we play with network settings on the machines. You know what? I don't even need to stop the stream. I can just continue on here and just give them the link to this one. And then when I edit, I'll just save it as a different name. Okay. This is the class. Oh, nope. That's the wrong class. So we're actually going to do database. This one goes until 3:45, so we still got a half hour. And I'll just go over everything anyway. So, feel free to hang out if you guys want to, but definitely not required. September 14th. Okay, now I get to do these live streams all day and then I edit them all night. It's fun. What am I looking for here? Alright, so I'll change this to organize these into playlists after I'm done editing them. Okay, so now waiting for people. I can pull up the PowerPoint. All right. Ooh, we don't need this. Yeah, we don't need that. Okay. Oh, what are the due dates here? Oh, okay. So here, yeah, let's see. So we can finish this today. There's that full screen. But it's gonna be too annoying, so I won't use it. All right, well, is anyone in here from database yet? See where we left off. Let's put my video in the video. That'll be funny. Man, internet is going so slow today. But I guess I am uploading live recorded footage. So Just got an email from a student who just got an interview. So if you are in the database, so much clickbait. Oh, my channel. It's over here. More channel. All right. Here is database. There it is. Where did we end this one? Was I using the PowerPoint? That's what I want to know. Yeah, I was. Okay. So how far did we? Okay, we're adding relationships. We talked about the one-to-many and many-to-many. Okay, so we can skip over that. Man, missing Monday, it really threw me off last week, so bear with me here. My head is just chopped off in this video. Okay, so I got 2 relationships, I think. Yep, all right, cool. Now we know where we need to start. How many people we got? 1. That is me. Oh well. Anyone that needs to can watch this later, really. There's no requirement to be here. Okay. Where were we? Chapter 2. Be able to fit that in there. Why is that so small? There we go. Huh. Well, that's... Oh, I downloaded it. Downloads. Did not download. Okay, so we started with talking about relationships. Remember, those are represented by a diamond, and they always go between 2 entities. Okay? Entities are represented by rectangles, and they represent groups of similar things, basically. So we were doing this hospital example. Doctors, there's a lot of doctors at a hospital, so that we need to keep track of, so that's a good one. Appointments, patients, rooms, prescriptions, these are all things where, you know, we have a bunch of them. They have a bunch of different properties and things that we need to store, so we can use these as our entities. How did we decide on these? Well, if you are consulting, you would just ask, you would say, well, what data do you need? Basically. It's not that simple. It takes at least a year or more, a little less, I don't know. Depends on the size, but they collect the information by watching the organization. Okay, so when you're adding your relationships, you draw a line from entity to relationship to entity. Okay, and so it's easier, I think, to take each pair of entities and think about how they relate. Okay, you can end up with cycles in your relationships, and you want to try to avoid that. But there's a lot of things you can adjust when you're creating an ER diagram for a database. There's so many little things you can adjust, and that you're trying to get the most efficient combination in your entity map so that you can build it with SQL. So it's like your blueprint. So you cut out the things you don't need, only focus on the things you need. Okay, so here, I'm having deja vu. I must have said this already. Doctors see many patients. That makes sense, right? Now, if I didn't specifically say in the prompt, doctors see many patients, what that means is in this hospital, you get to decide. So if you want a hospital where doctors only ever see one patient ever, you would put a 1 there. That's pretty ridiculous, so, I mean, could happen, I guess, but the most logical choice would be many on this side, and how many doctors can a patient see? That's also many, so this would be a many-to-many relationship, M and N. Okay? But before you start deciding the relationships, you should connect your entities together. All right. So here we do have a cycle. Doctors prescribe prescriptions. Doctors can prescribe many prescriptions, but a prescription can only be prescribed. So each, like if you get a prescription, only one person is gonna prescribe that to you. Someone else could prescribe it to you later, but that would be a different prescription that we would keep track of separately with a different date and potentially different doctor. Could be the same doctor, but it's only ever 1 per prescription. So that's a 1-to-many relationship there. And we want to talk about logically. So doctors, they write out the prescriptions, the patients take those prescriptions, and we already talked about doctors and patients. So, not to confuse you, but a prescription is only prescribed to one person, but a person can have multiple prescriptions. That means both prescriptions and patients is a 1-to-many, and prescriptions to doctors is a 1-to-many. And the one side is prescriptions are prescribed to one patient. Prescriptions are prescribed to one doctor. When you have that and the ones are facing 2 different entities and the manys are facing 1, you can actually convert this into this 2 1-to-many relationships into a many-to-many relationship. Okay? This is one of those things where logically you just build it out and then you look at it again and you look for any weaknesses that you can improve on. So that's basically, yeah, I'm looking at this and that's what I was like, I just told you cycles are bad. And then the first ER diagram we pull up has a cycle in it. So the reason this is a cycle is it should be patients go to appointment, and a doctor is assigned that appointment. So, yeah, or you can use a many-to-many, but you could break it out into 2 1-to-manys, because an appointment only ever has 1 patient, and an appointment only has 1 doctor. unless you're really sick and you need multiple doctors for a single appointment. Again, if I didn't say it specifically in the prompt, you're allowed to make whatever assumptions you want. You just have to be able to, if I question your judgment, I'm doing that to try to help you make better decisions, but I want to hear why you did it that way, because I don't always think of everything. It's really easy to plan out a database, and it's really hard to build it and implement it in a large organization. So the worst thing in the world is to implement something and then after your year of consulting and building, and you implement it in the company, and then you find out it doesn't work or it has crazy load times or something because your records are pulling up wrong. So that's the kind of thing we want to fix while we're making the ER diagram. And that's why I start this class about learning about database design. Okay. If you don't understand database design, it's really easy to make a terrible database. And if any of you are planning to work in programming or web development, you will probably need to use a database. And if it's already been built by someone who just went to a website that taught you SQL, it's going to have a lot of the issues that I'm teaching you to avoid. Okay? And then you have to do workarounds, and it's a nightmare. So you want to build it right, plan it out right from the beginning. That's why we spend so much time on the planning. Because if it fails, the company might have just lost $1 million on all that. Okay. So now that we know how our things are fit together, okay, I already went over this. I think. Oh yeah, because we're down here. Okay. So this is the ER diagram that I came up with. First draft. Again, creating an ER diagram is an iterative process. I didn't explain what that means before. It means you're going to make it, and then you're going to edit that one, and then you're going to edit that one, and you're just kind of shaving it down to the bare necessities. Okay? It'll work a ton of different ways, and sometimes a lot of times it'll still work if things aren't the most efficient. But if there is a way to make it the most efficient, why not do that? It gives you a huge advantage over other people that don't know how to do it, that get hired, because you'll see this if you get a job in it. I've seen it so many times. Okay, primary and foreign keys, I'd mentioned those before. I'll talk about it again. So inside of an entity, all right, primary and foreign keys. Let's talk about doctors and appointments real quick. What do you think the primary key would be for doctors, and what do you think the primary key would be for appointments? So, doctors, remember, a primary key is some data, so some value that's unique between instances of the same entity. That's a fancy way of saying, everybody needs a different name, basically. So, we can't use name, though, as the primary key, because people can have the same first name, same last name, and even live at the same house. So you can't use address. So what is actually unique? Well, probably something like employee ID number. Social Security number is unique, but there's a lot of business rules regarding using Social Security numbers. So you would, at this point, try to avoid using Social Security number, because it's not that easy it's not that hard to switch to it later if it's the best solution. Some organizations really need people's social security numbers, and some really don't. Okay, so primary key of doctor would be like employee ID or doctor ID even, because there are going to be different employees that we'll probably keep track of that I haven't included in here. Appointments. What do you think a good primary key for appointments would be? Well, this is a situation again where we have a one-to-many and a one-to-many relationship on both sides of this, and the ones are pointing at two different entities and the manys are pointing at one. Okay, so this could be converted into a single one-to-many, but the way it is, we could technically use appointment number. We could use a combination of the time and the doctor, because that would prevent anyone from being scheduled at the same time, because if you tried to enter that into the database, it would say that value is already in there. I guess you would have to include the day, time to the nearest minute, and depending on how. Anyway, I'm running through the whole series of questions I would ask them. Anyway, you could just use appointment ID. We'll talk about composite keys more later, very soon actually. Okay, so those would be good for primary keys because it's unique. Okay, just every appointment will just get a new appointment ID. So the first appointment we ever have at the hospital will be appointment 1, the next one will be 2, and so on and so forth. Okay, but what about foreign keys? All right, so we have to deal with foreign keys in every type of relationship. Okay, and I added this one-to-one relationship in here because, you know, I don't want you to be surprised if you see it. It's just fairly rare because it's only, I feel like one of the only reasons it's done is to be more efficient on loading specific information in certain situations. So that one you really have to, know what's important to decide that. Okay. But let's take a look at a one-to-many relationship. Let's go back to doctors and appointments. So what was doctors' primary key? It was doctor ID. I think I have them down in here. Okay. Let's just do it this way. So in a one-to-one relationship, here we have two entities and the relationship. These down here are the information that would be stored in a table. This is basically the table view of what this will become. This ER diagram will be a blueprint for designing your tables, and then from your tables you will design the SQL to create your database. So that's what these are. These are just tables of the rows are records. Okay, you can call them rows, you can call them records, you can call them tuples, T-U-P-L-E-S, tuples. If you're doing research, you're going to see all three of those terms used. They mean the same thing in terms of a table in the database. The first row here is the list of attributes that this table has. So this is the contact info, patient contact info. So we need a primary key, so we use patient ID. So those just have to be different. And then patients, well, they also need an ID. So here, we're using patient ID as the primary key, and we're using it in both. Because it's a one-to-one, every record in this first table will relate to exactly one record in the other. So, the primary keys are patient ID. The foreign keys here, the foreign key is also patient ID. And you can do that on either side. It doesn't matter in a one-to-one. You could use the patient ID and patient contact info as the foreign key, or you could use patient ID in patient's table. Now, since patient contact info is kind of a sub-table of the patient's table, that's probably where you would use this one as the foreign key, because you couldn't have contact info if you didn't have a patient. So, all right, so we're done with the one that we probably won't see very often. Now one-to-many. This one we'll see all the time. So again, we have the relationship at the top. It is a one-to-many relationship, and I've listed the primary keys here. And let me just go back real quick. You may notice that this foreign key is the same as both of these primary keys, but the reason it is patient ID is because to create a relationship between two tables, you have to use the primary key from one table as a foreign key in the other. And there's no rule about if whether a primary key can be a foreign key or not. In a one-to-one relationship, it can be both pretty easily. Okay, so keeping that in mind, because this one has an illustration and I want to explain what's happening here. So, primary key patient ID, primary key appointment ID. So, pretty straightforward. Coming up with a primary key is probably the easiest thing to do. Foreign key. Once you've decided the primary keys and the type of relationship, you don't even have to decide what the foreign key is, because it's always going to follow the same rule. The primary key on the one side of the relationship is going to be the foreign key inside the many side. So patient ID is the primary key of patients, and it's the foreign key of appointments. So if we look at the appointments table, it has appointment ID and patient ID in here. Why do you think we need to include a patient ID in the appointments table? What is useful about that information? What does that tell us? Okay, and we have two people watching, so see if you can think about it, and then pause if you want, but I'm going to go ahead and talk about it. The patient ID here tells us, this is how we read this. Appointment 1 is in the red room, and it's patient 1. When someone looks at that record, later on you'll see this, we can present it however we want. We can actually say, okay, patient ID 1 is Jim Smith, and so when the computer outputs this data, we wouldn't tell them just the patient ID. We could give them the patient ID, the first and last name, the location. All right. Now, if we look down here, why does Jim Smith have 2 lines drawn? Okay. Take a look. Think about it. And why does Bob Anderson only have 1 line here? So Jim Smith is pointing at appointment 1 and 2. Bob Anderson is pointing at appointment 3. Why is Jim Smith pointing at these 2? Because they have his patient ID. He is the one that's going to go to these appointments. Bob Anderson, his patient ID is only in 1 record, so he has 1 appointment. All right? And so that's what the foreign key does. It connects tables together. That is truly what a relationship is. Okay? It's when you're looking at the diagram, I'm mostly expecting you to learn the terminology and the actual diagramming principles or standards, whatever you want to call it. The Chen's notation. We're using a very simplified Chen's notation here because of the examples we're using are fairly simple. Okay, so you always take the primary key from the one side and use it as a foreign key in the other side. Another thing, and you can see it here, foreign keys do not have to be unique. Okay, primary keys do. So if a primary key is a foreign key, it also has to be unique. But if it's just a foreign key, it does not have to be unique. Okay? Because if the patient ID had to be unique, you can always logically figure this stuff out. Just think about it. What if this patient ID always had to be different? That means Jim Smith could only ever have one appointment. And that's not what we diagrammed here. We said patients can have many appointments. Okay? So every line drawn from these guys could go to multiple things. Okay? But every line coming from these only points at one person. So 3 points to Bob Anderson, 2 points to Jim Smith, and 1 points to Jim Smith. Okay? You'll never see 2 lines coming out of this. Okay? You won't see lines coming out of anywhere unless you use Access. It has a nice little thing in there, graphical representation of relationships. Your graphical representation of the relationship is the ER diagram that you created. Okay? And for these, if you're working on ER diagrams, I have shown you I've given you the link at least to draw.io, free diagramming web-based tool, so you don't have to install anything. Okay, and then from here I'm just going to create a new diagram, and I can just create a blank diagram. You could do this on paper and scan it. Some people like handwriting these better. The thing is, the way they grow by adding entities and relationships, it's really hard to plan out where things are going to go. So you might have to erase, or it will look wonky. If you do it digitally, you can just drag things around and restructure it fairly easily. So that's what I recommend. Okay, I don't know what it's asking me for here. Oh, save as. Okay. We'll just throw it in here because I'm going to make a junk thing. So it's making me save it to my computer so that I don't lose it if computer crashes or power goes out. Okay, so building your diagrams is as easy as dragging these out here. Maybe we'll have doctors, and then we'll have patients, and then you put in the relationship. Okay, and then you can use these tools. Right here, you can click that, and it'll connect to the nearest thing there, and this will connect here. Now, you'll notice in our ER diagrams, the lines do not have arrows, so to change that, you just click here, and then you choose rounded is fine, probably. No, that's not what I'm looking for. Here it is, the head. What kind of head do we want? We want none. Okay, and once you change that setting, so I'll delete this one. I think once you change that setting, from then on, the lines you create will follow that, which is nice. So you don't have to make sure you set that first, or else you're going to have to go in. You could probably select these, this, and if I hold Shift like that, I can grab both of them and then change them all at the same time. But just change it for the first one immediately, and then you won't have to run into that issue. Okay, so let's say I need to move this so I can see better how these are related. The lines adjust, which is really nice. No erasing. Okay, anyway. If you're going to use this to turn in, okay, you actually have to go to File, Export, okay, and then if you recognize, these first two are image files, so you can choose either of these, then it will download your diagram as a picture file, so you'll save that somewhere where you won't lose it, and then you can attach that to the assignment. Or if you're in the Word file, you can just put the picture in the Word file under the exercise, and that's pretty straightforward. Okay. Now the most complicated relationship. It just has an extra rule in it. So here, doctors can see many patients, patients can see many doctors. Primary key of doctor is doctor ID. Primary key of patients is patient ID. Okay. You don't see any foreign keys inside the entities in a many-to-many relationship. Okay. What happens with a many-to-many relationship is it actually becomes its own entity that represents an instance of a relationship between two other entities. If that doesn't make sense, it's okay, because just like the other two, once you decide on your primary keys and your relationship types, you don't have to think about other than, you're not making any decision. You just have to, you always follow the same rule. Okay, so in a one-to-many, we take the primary key from the one side and put it in the many side. In one-to-one, you can do it either way. But with a many-to-many, you will create a relationship, a new table, okay, and its attributes, at a bare minimum, need to be the primary keys from both tables, okay? That will become those attributes inside of this new table are individually foreign keys back to the other tables. So, again, if you just follow through, it all makes sense. It's a lot to take in the beginning. All right, so here we have a patient ID of 1, which is Jim Smith, and we have a doctor ID of 3, which is Sarah Sweedler. So if I have 1, 3 in this table, which represents the relationship between these two entities, what does that mean? What does 1, 3 mean? What does 2, 3 mean? And what does 2, 1 mean? Okay? What that means is Jim Smith has Dr. Sarah Sweedler. Sally Jones also has Sarah Sweedler, but Sally Jones has another doctor, Greg Ackerman. All right. So when a many-to-many, you always follow this step, okay? And so look at so down here where I'm listing the primary keys and the foreign keys, I do want you to write that when I'm asking you to put in the primary keys and foreign keys. What I'm asking you to do is include text telling me what the primary key and the foreign key are, so that I can see that you understand how the relationships work. So in a many-to-many, you actually have to put these on the relationship. So under the relationship here, I've placed them. Like I said, patient ID is a foreign key, doctor ID is a foreign key. The primary key has 2 attributes, okay? So what that means is you can combine attributes to form a primary key, okay? What that means is the combination of these 2 values has to be unique. So if I have a 1, 3 here, I cannot have another 1, 3 anywhere in here, because that tells me that Jim Smith's main doctor is Sarah Sweedler. If I put that in there again, it's redundant data, okay? So what we do to represent that primary keys in this join table is you just use those 2 the foreign keys from the 2 tables. You just make a composite key like this, okay? All right, so that's called a composite key. talked about primary and foreign keys. So you can look at this diagram that's completed up to the point where I added in the primary keys and foreign keys, and you'll see everything that I talked about is every one of the relationships follows that same thing. So when you have all the entities out here, it looks like, you know, a mess. But once you understand what each of these are, it makes sense. So here we have the doctors and prescriptions. Okay, I'm glad I talked about this because we have so doctors prescribe prescriptions, one-to-many. Patients are prescribed prescriptions, many prescriptions, but to only one person per prescription by each doctor. So take a look. If we were going to represent the relationship between doctors and prescriptions by using foreign keys, what foreign key would I add to prescriptions? Or what foreign key in prescriptions represents the relationship to doctors? That's doctor ID. We also have another foreign key, patient ID, but that has nothing to do with the relationship between doctors and prescriptions. The reason that's in there is because of the relationship between prescriptions and patients. Okay, so at this point, I don't even need to logically think about the relationships. If I just want to get the keys in there, all I have to do is look at each, I almost called that a triangle, each diamond, and see, okay, this is a one-to-many, so all I have to do is throw this as a foreign key in here. This is a one-to-many, so you always take the primary key from the one side, put it as a foreign key in the many side. Okay, once you've added those foreign keys, you can just put them together, or I'm sorry, once you have the foreign keys in there and a one-to-many, you're done. Okay, now you know when you build this table, at a minimum, you'll need these three fields. We'll add more, but these are important for the structure of the database and the way the tables are related, and is one of the most important things to speed up access to your database is controlling how you set this up. Okay, so if I can reduce the number of attributes I need, if I can reduce the number of entities I need, all of those things go really far. Okay, you want to reduce redundancy for sure. So you don't want extra copies of things you don't need. They just take up space and time. Okay, anyway, so we saw some one-to-manys. Here's a many-to-many between doctors and patients. Okay, primary keys are added as foreign keys in the relationship. It will actually become its own table with a primary key of a composite primary key of both attributes. Okay, and so you can look at the other relationships and see that I followed this rule for every entity and many-to-many relationship. Or every relationship I've set up the foreign keys and the primary keys for this correctly. So if you want to take a look at a diagram you've created and you want to double check, you can say, okay, one-to-one, here's how we did that, or one-to-many, you can take a look at that. Okay. So one of the more important parts of designing an ER diagram, and I know I've said this twice already, it is an iterative process. Okay, so whenever you think you're done, you're not done. Okay, in this class you are, but in reality, you're going to spend a lot more time. You only have one, most likely you only have one database to diagram out. It's going to be huge, but potentially. But once you're finished, it's time to go back and double check everything. So for example, some of these questions that you might ask of the organization or of yourself. Do we need a table to keep track of different prescription drugs and a table to track when those drugs are prescribed? By who to who? Okay, so I don't even see drugs in here. Let's see. Oh, the point is, do we need a table? So do we need to add a new entity called prescription drugs? And then inside of there, the records would be like, I haven't been sick in so long. Penicillin. That's penicillin. And then it would have some properties, like these are the medicines that you can't take this with. That would actually be another table with relationships. That would be a whole thing, okay? Should we tie the act of prescribing drugs to the appointment in which it occurred? So remember, I said you don't want cycles. You want to try to avoid cycles. So here, because patients is related to appointments, doctors, and prescriptions, there's going to be 3 copies of that, or there's going to be a lot of copies of that foreign key. Okay, there's one. Here's patient ID here, patient ID here, patient ID here. Okay, if we could somehow combine these or add something that reduces the number of relationships, then we can make it more efficient. Okay. I need to stop moving this up and down what you guys are trying to do. Okay. Should we? Okay. Try adjusting your model to meet these requirements. So if you guys want to try this, see if you can refactor this to include prescription drugs as an entity. Think about which tables that would connect to. Okay, which entities would it have a relationship to, and what would its primary key be? Okay, and then what would the relationship type be to the entities, and put in the foreign keys. Okay, so try that, and if you want to email it to me and ask how you did, I can take a look at that. Or if you're having problems on any of the homework, definitely email me. And I've done Zoom meetings with students one-on-one, so I can share my screen and you can share yours, and we can talk, and I can walk you through things, which is much easier in explaining technical things like this than it is through email. So I'm totally okay if you just have a simple question. Definitely email, but if you want a better explanation or a walkthrough, email me and we'll make an appointment. So. All right, so we are up to ER Diagrams Homework 1, which was due September 7th. So if you haven't done it yet, try doing it on your own, because what I want to do is go through, maybe I'll go through 1 or 2 of the trickier problems here, and then if you want me to do more, you just have to ask. If there's one that you weren't sure about, just ask. Okay, so let's take a look here. Okay. Keep adding I've been adding problems to this, and they're more complicated towards the end, I think. All right, so let's try 10. Create a database for a website that matches employers with new employees. All right, so what is the first step? That is listing your entities. All right, so I'm going to delete this, and I'm just going to add this in, and we'll make a list using this. Entities. All right, so basically, what is that called? One of those job finding agencies, but it's online. What are those called? Can't think of it off the top of my head. Okay, let's center this. Nope, doesn't like that. There we go. Down here, go back to left align, but we will put bulleted list. Nope, it's not going to let me do that. It has to center the whole thing. Okay, anyway. So think about what data we need to store. All right. So we have employers and we have employees. Prospective employers, prospective employees. All right. So employers, employees. All right. We could have jobs, because some employers are looking for more than one type of employee. So we can keep track of those with jobs. So employers will be able to create new jobs, and those will get stored as individual records tied to them by their employer number in our website, to keep track of which places have which jobs. Let's see. So I think that's actually enough for this one. So I like you guys to kind of try these on your own in the beginning. So if you guys have just created all of your diagrams already, and as you're watching this, you're noticing like a bunch of mistakes you made, I will, what I'd like to do is have you understand the mistakes you made and what the correct way is, because that's the point of this class. So whether you do it by the due date or you do it by the end of the class, it's going to be the same. So if you wait till the end of the class to do all this stuff, though, it's not going to work because it's fairly complicated all together, but in chunks it's much more digestible. Okay, so next step, I've listed my entities. All right, so I probably do that on a, in the corner or something. The next thing is to put them in. So we have employees. Okay, we have, you can copy and paste these too, which is nice. We have employers, and we have jobs. Okay, we're gonna want to keep track of, it would be really nice, and I've seen websites that do this, if we could store on our website employees' resumes and cover letters and transcripts, basically everything you need to apply for a job. If we could store that for employees, we could save them a lot of time of typing. So I just thought of a new entity. So jobs, employees, employers, but we want to keep track of also documents. Okay. All right. So I think that's good enough for now. So we need, what's next after we have our entities? We need to put in the relationships. So the employee can upload their resume and transcript documents so that they'll automatically be included with an application. Sometimes, if you're applying for a lot of different jobs, you may gear your resume differently. So maybe you'll have multiple resumes for different types of jobs you want to apply for. Okay, anyway, that's definitely, we want that relationship. Okay. Does documents relate to jobs or to employers? I don't think so. Maybe you think differently, and if you map that out and we talk about it, we can figure out. Because there's never one right answer. There usually is a best answer, but finding it takes a lot of time. The more time you put in, the better it's going to be. And not that I expect you to put in copious amounts of time here, but if you were doing this as a job, it would be expected. Okay, so we know these are going to be connected, so stick that there. Okay, so it remembered my line rules. We'll stick that there. Okay, so employees, upload documents. And the names on the relationships are really for the person designing the database to understand that relationship. Okay, so sometimes you read them one way, sometimes you read them another way, but employees upload documents, but documents are uploaded by employees. So that's the relationship. What type of relationship do you think this should be? Think about it for a second. Should it be one-to-one, one-to-many, or many-to-many? So this is where you just apply your logic. So this is one you have to figure out based on, it's supposed to be based on the analysis, but I didn't say anything about documents in the prompt. So I'm just making an assumption that I think it would be a better website if the employees, prospective employees, could upload documents to use in the applications. So that's why I included that. See, I can explain why. So if you do things differently than me, as long as you came to that conclusion using logic and it makes logical sense, it is a good answer. Okay? And so what else? Okay, so jobs. So employees apply for jobs. Employers post jobs. All right? So we'll put those in there. You can definitely let's see. You can definitely fast forward this part. If you want. Okay. Jobs are posted by employers. And copy this. Being able to use a computer well helps a lot. So when you select this once versus selecting inside of the text, you're selecting actually something different, so you have to be careful. So I want to select this object, Control C, Control V, and then I can, as long as I see the four-headed arrow, click and drag. That four-headed arrow represents moving. So it's a context-sensitive cursor. So if I click out here, I'm not going to be able to move it. This is the selection cursor. This is the move cursor. And then here, this looks like a custom cursor they added because it's all jagged and weird looking. But it has a plus sign, so you just have to know that when you see that plus sign, it's going to do what it does when you click this. So anyway, connecting these. Ooh, got a curly one there. All right, it doesn't have to be lined up perfectly. I think I set these lines to have a round curve on accident. So you can do rounded, curved, or you can stick to sharp. Okay, doesn't really matter as long as I can see where the line's coming from and going to. All right, so we have relationships and put in. now we need to decide what type they're going to be. So again, I was talking about, this is the part where you apply the logic. So employees upload one or many documents, and documents are uploaded by a document. So one employee can upload. So I'm going to say this, but I'm going to try to explain it at the same time. So when you're thinking, if you say it out loud, it becomes really obvious, okay? But when you're saying it out loud, you start at one entity and you think, okay, one record in this table, so one employee, okay, and this has nothing to do with the relationships yet. You think about one employee. How many documents can one employee upload? One or many? Well, we already said we wanted many, so I can put an M on there. So you just select the line and you can type on it. So a single document would be uploaded by how many employees? One or many? If a single document can be uploaded by multiple employees, that just doesn't make any sense, because when you upload something, it's always from one computer, and I'm imagining this website would have an account information, which would be in this employee thing, and so as part of that account, your uploaded documents would be attached to one person. So each document would be uploaded by one employee. So this is a one-to-many relationship. Okay, and remember, one-to-many, it does matter which side has the 1 and the M. So those are tricky in that you have to double, if you just do the logic thing I just did, you can do it pretty easily. Okay, employees and jobs. So an employee, whoops, why did I name this? Oh, I never changed it. Okay, an employee applies. One employee can apply to how many jobs? Well, we would be a really bad website if you could only ever apply for one job. So an employee can apply for many jobs, and then one single job can be applied for by one employee or more. Well, employers wouldn't use our site if we only ever gave them one option, or we limited it to the first person that applied. That would be terrible. So we want multiple employees, multiple people to be able to apply for jobs. Okay. It's kind of weird calling this employees, because that kind of says they already have a job, which you could already have a job when you're looking for a job. Professional tip: if you have a job that you like, you may be tricking yourself, and you should always be applying to new jobs. Okay, whether or not you decide to take the job, you'll be surprised at what kind of opportunities you'll uncover. So a few years ago, I started applying to a different job every day, or not every day, geez. Filling out applications is the worst. No, I lost my train of thought. Anyway, applying for jobs. Oh yeah, I was applying for jobs once a month. Getting the interviews is awesome first, and then getting offered the job. Well, after that, if you get into a further interview, that's pretty cool. Like, it makes you feel really good about yourself. And then if you actually get the job, you can say, all right, do I want to move to this new job? If it pays more, or I don't get along with the people I currently work with, or it has benefits, or it's in a place that's nice and the place I work is not nice. but you get to decide, and it's no problem if you say, you know what, take me out of the running, because their application process, they have people they can go to immediately after you, so it's totally normal to do that. And then they have your information, so if you ever apply again, or if they have some kind of other opening, they may contact you. So it really gets your name out there. But anyway, if you don't get the job, you can just say, I've got a job. Oh well. Big whoop. I'll apply to another one next month. Or next week. If you don't have a job, and you want one, I highly recommend applying for jobs every single day. You have to cast a very wide net. And unfortunately, if you have an associate's degree in this kind of field, you really have to make yourself stand out, because you're competing with people who are going to have maybe bachelor's degrees and stuff. I'll tell you this: if you do this program and you survive through the programming program, for everyone else, I guess this is kind of a moot point, but if you're in programming major and you're survive this course, I'm confident that if you get through every course in this program, you are ready to become like a junior developer, web developer, or at the bare minimum, a QA, quality assurance, who basically is like a video game tester for software that isn't games. All right. Okay, back to the diagram. Man, I need to stop rambling. Okay, so jobs and employer. So an employer, I'll just move a little faster here. An employer should be able to post, one employer should be able to post multiple jobs. A job should only come from one employer, right? Does that make sense? Doesn't really, you would never be hired by two employers for one job. That would be awesome, but it would be very unethical. So here we go. So a job can only ever be posted by one employer. Okay? All right. So we've got our relationships in. Now let's add in our primary keys. This is pretty easy. This will be an easy one. So employees, primary key will be employee ID. And I shorten these so I don't have to write out all the words. Hey, you guys can do it too. This is not a typing class. Being able to type helps. So, all right, so there's our primary key there, and now I can just copy this. Make sure I select it correctly. Copy it for here. So every one of these entities is going to need primary key, right? This is why doing this digitally is good, because if I put this in a place, that blocks this from expanding out, I can just move it. Okay, so there's my primary keys. Now it's time to put in the foreign keys. So at this point, we have our relationship types, one to many, many to many, and we have our primary keys. Oh, I guess I should change these. So how about for document, we use document ID. For jobs, let's see if you guys can guess what we're going to use. Job ID. And employers, okay. Names of primary keys do not need to be unique. The values do. So this primary key, EID here, that's the EID inside the employers table. It is not related at all to the EID inside of employees and employers. Okay, So this is employers.eid, and this is employees.eid. Okay. So this one, okay, so we can keep that there, that's fine. Or you can change it too. It's really confusing if you use two primary key names that are the same in a many-to-many relationship. So let's do, we can call it EMID. It's really, it's a good idea to make the names so that people understand what the attribute is, okay? Because once you're done here, anyone who's developing the software that will use this may have to grab the data out of these tables. And so, if your employers have an attribute called wiffle ball bat or something, and you call it that, but that's their name, it may confuse anyone that's trying to use that. So you are free to name things whatever you want, but it's within usefulness. So primary keys, pretty straightforward. But let's do the foreign keys now. Okay, so what is the rule? You take what? You take the primary key in a one-to-many. You take the primary key from the one side. Okay. And what do you do with it? You put it as a foreign key in the many side. So you select this, FK, oops, I'll capitalize that to be consistent. Okay, so we just created the relationship between these two tables. Okay, so we can see all the documents that each employee has uploaded, and the employees will be able to see their documents based on the EID in the documents table. All right, let's do the other one-to-many. Okay, so here it's the one side, right? We grab the primary key, and we stick that in here as foreign key. Okay, so now I have this relationship done and this relationship done. Now we'll move to this one, many-to-many. All right. Remember, there's an extra step in a many-to-many, and that is creating a new table. Or basically the relationship becomes an entity. And that entity needs primary key, it needs a primary key, and it needs a foreign, in this case it's going to have two foreign keys because it's connected to two tables. Okay, so what is the primary key going to be and what is the foreign key going to be? Right. If you remember when we did the example on the slides, with many-to-many, you have two foreign keys, all right? You have EID, because that's the primary key from one of the tables, and you take the primary key from the other table, and you stick it right here, so job ID. So now we know that this new entity is pulling information from employees and from jobs, and the primary key is always, at a bare minimum, I should stop saying always. In this class, with the examples that we're doing, your many-to-many will pretty much always use a composite key of, I'm using a touchpad, I just reached for the mouse. Okay. The combination of both primary keys of the related tables. Okay. So that's EID and JID. So that means every record in this table will have to have a unique combination of EID and JID. So that way we don't have redundant data. And then this is going to tell us which employee applied for which job. If we want to know their name, we use the foreign key here. That'll bring us back to here, and we can pull all the information about that employee. If we want to pull the information for the job for that application, all we have to do is find the job with that JID in that record. So hopefully this is helping you see things come together. Teaching it design first like this, again, is supposed to help you when we get to the actual putting things together that do stuff inside the computer. We want to do it right from the beginning. Okay, so I'm showing you this process so that you could after you learn this process, you could take any organization, any business, if you wanted to create a database for anything, all you have to do is follow these steps. So if you're creating it for something for you, all you have to think about is, what data do you actually want to store in that database? So let's say you want to make a database of your baseball card collection or something. You could have a table. You would really only need a table for one table for that, right? And you would have attributes. But once you had it in the database, then you could search that and see what you have, or the quantity, or whatever, however you want to do it. Okay. So anyway, by the end of the class, if you do everything, you will be able to take any organization. Okay. So any kind of business, or if you're in a club on campus and you want to represent the data that organization needs, you will be able to do that. Okay. And everything we're doing is a process. The entire class is just, we're going to start by learning how to design a database, then we'll design it, then we'll implement it, and you will know every step to be thrown right into any kind of database problem. Now, databases, or learning about database, obviously I can't fit every single thing in a 16-week course. So you will have the basics to build off of, that if you ever get in a situation where you need to do something with a relational database and you don't know how to do that, you'll know the basics enough to look it up. Okay. All right. So we have, checking the dates again here. How many people are watching? 2 still. Okay. Okay, what was it? I wonder if I should post this. This is pretty, I made a pretty good diagram here. Okay, anyway. Oh yeah, when is the next thing? So if you haven't already, let's see how many people have done it. We have the ER diagram quiz, which is going to ask you to follow these steps. You can use, it says quiz, but you can use any resources on it. All right, what I expect you to do, and you can do this one of 2 ways. First, download it don't print it out of here if you can, because it's messed it all up. But if you download it here, you'll be able to either print it out or edit it. If you print it out and want to draw on the quiz, you'll have to scan it back to me. Okay. If you have a smartphone, there's a really great app called Adobe Scan, and I use that basically for everything. For work, it's just a free app, but it's very useful. So you could scan that in with that app, or you can download it, open it, and just type in your answers. If I ask you to make any diagrams, all you have to do is come to draw.io, create your diagram. I would save it afterwards, but to be able to, that just saves it so that you can re-edit it on draw.io. This doesn't give you the file that I need. The file I need, you have to go to export and choose one of these options, either PNG or JPEG, and then once you download that in Word, just following through here, a lot of you guys probably know how to insert a picture in Word, but just in case, if you don't know, that's fine. If you have a Mac that doesn't have Word, you might have to use the school's VM, so contact me and I'll help you out with that, because it does have Microsoft Office. Okay, so here, I'll follow through. I want to post this is my answer to the quiz, okay? I'm going to export as PNG, okay, and then do we want a shadow on it or a grid? All right. Let's include a copy of my diagram, of course. Why else would I do this? Okay, so I'm gonna just throw it in. Let's download it to my computer. I need it there anyway. I'm just gonna throw it in downloads, and I'll call it 111.png, because now when I go to my documents, I'll be able to see it at the top. Okay, so in Word, once you have the, come here, sit, sit, girl. Sorry, animals are fighting. Okay. If I had an infinite time, I would edit out these pauses. I'm sorry. Okay, inserting the picture, right. Okay. So I'm going to click, okay, I'm not even describing what I'm doing. Okay, go to Insert, Pictures, from this device. This will show you everything. So if I go to Documents now, no, Downloads, that's where it was. Oh, I guess it's sorted by date modified on mine, but if it was sorted by name, one's going to show up first. Okay, so I can delete that later. It's a good idea to periodically clear out your downloads folder if you're worried about computer space. So I just insert that in. And then once it's inserted in, on Word, if you want to be able to manipulate it easier, what you do is you click this and you choose either behind text or in front of text. If you do behind text, I don't think it'll cover up any text. And then once you do that, that gives you the freedom to kind of adjust and move it around. The default inline with text, it doesn't let you move because it goes with the flashing beam thing, this down here. So you can literally move this as if it was letters, which is not as useful on a quiz where I have things all over the place. Then you want to use behind text, and then you can shrink it down if you need it to fit, okay? And then you move on, okay? So that's how you do that. Anyway, if you are having problems with the quiz, I would not put it off, because if you're having problems with the quiz, you can email me, and I will give you some help. I think I have... check here. I have something. Did I get rid of that? Okay. I think I have a video Well, I'll create a video of me going through the quiz, and that way you guys can see exactly what I was thinking for each problem. Okay, but definitely start on it now, and or as soon as you can, and ask me if you're not sure what is expected of you for that. All right, so I think that's enough information for today. I'm planning on doing another live stream next Monday, and then we'll move on, and maybe we'll take a look at some of your ER diagrams. If you if you have questions about anything on your ER diagrams that you're not sure if it's right or not, just bring those to my attention and I can explain it. I will tell you that through the course, we are taking those 10 prompts that I gave you for the ER diagrams, and we're going to follow through implementing those. So you want your ER diagram to be correct enough before you move on to the next step. Because what will happen, and the reason we do these in steps, is because I can look ahead and see what problems we're going to run into for some things. But every step, if you notice something's not working, like if we're putting in the relationships and it's just wrong, eventually we'll get to a point where that is breaking something, and then we'll have to go all the way back to the step. You know, if it's an issue with the ER diagram, we have to go all the way back there and start over with that, because it's an iterative process, like I said. But anyway, it's an iterative process. If you start it on the first day, the quiz, you will not have any time to iterate. I'm just trying to say things that'll get you to do it earlier. Okay. I'm going to end the stream here, so I'll see you next week. Thanks, guys and gals.